Right now, at this very moment, a traveler from the void between stars is navigating our solar system, and its presence is forcing a quiet, urgent debate among NASA scientists, compelling them to reconsider the fundamental laws of physics as we know them. This enigmatic object is designated 3I divided by Atlas. What it's doing is, by all accounts, a physical impossibility. I'm referring to behavior so out of the ordinary that when the initial data streams arrived, the first assumption among researchers was equipment failure, but every diagnostic confirmed the instruments were functioning with perfect precision. And what they are detecting hints that we might be observing an event far more profound than the mere passage of a comet from interstellar space. Let me be unequivocal. In my 50 years as a theoretical physicist, I have seen the scientific establishment repeatedly set aside extraordinary findings simply because they did not align with our established models. But with 3I divided by Atlas, we no longer have that option. The anomalies are accumulating with such speed and consistency that even the most orthodox astronomers are now posing questions they once believed belonged only to science fiction. And the most deeply unsettling aspect, the official channels are telling us far less than what they almost certainly know. To understand this, we must go back to the beginning of the story. On the 13th of September, 2024, astronomers utilizing the Atlas Survey Array in Hawaii flagged an unusual object penetrating our solar system from the interstellar medium. Initially, it appeared to be just another cosmic wanderer, maybe a cousin to Oumuamua. The bizarre, elongated object that baffled us in 2017, or perhaps more like Borisov, the more conventional interstellar comet we observed in 2019. It was cataloged as 3I divided by Atlas, officially becoming the third confirmed interstellar visitor to our cosmic home. However, within a matter of weeks, it became starkly apparent that this visitor was different, radically different. The first major discrepancy arose from the most fundamental gravitational analysis. As 3I divided by Atlas passed Mars on October 3rd, 2024, at a distance of 29 million kilometers, a fleet of spacecraft was watching NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express and Trace Gas Orbiter, and China's Tianwen-1 mission all had a clear line of sight. Their purpose was to measure the deflection of the object's trajectory by Mars's gravity, a calculation so fundamental that Isaac Newton could have done it 3 centuries ago. But this is where reality began to warp. The gravitational effect was nowhere close to what was predicted. Based on the object's observed dimensions, estimated between 5 and 46 kilometers across, depending on assumptions about its surface and composition, it should have a mass of roughly 33 billion tons. To visualize that, imagine the mass of over 5,000 Great Pyramids of Giza combined into a single body. An object with that much mass passing so close to Mars should have generated significant gravitational disturbances, creating measurable shifts in the orbits of Martian moons and our own spacecraft. Instead, the gravitational influence it exerted was virtually zero. It was, for all intents and purposes, undetectable. For a trained astrophysicist, this is a paradox as jarring as watching a steel cannonball and a child's balloon exhibit the exact same gravitational pull. It tears at the very fabric of our understanding of the relationship between mass and gravity. This leaves us confronting 2 deeply problematic scenarios, neither of which has a place in our current playbook of cosmic physics and chemistry. Possibility 1. 3I divided by Atlas is composed of some form of exotic matter with a density lower than any naturally occurring substance ever conceived, a material lighter than man-made aerogel, effectively invalidating the entire periodic table. Or the second, more troubling possibility, there is significantly less physical substance inside this object than its external appearance leads us to believe. The physics, again and again, points to one explanation with more insistence than any other. Its interior is empty, a shell. Let me be perfectly clear. Hollow comets do not form in nature. It's crucial to understand why this is so fundamentally jarring. Comets are born from a process called accretion. Billions of years ago, in the frigid outer reaches of distant star systems, particles of dust and ice slowly coalesced, their mutual gravity pulling them together. This process, by its very nature, creates dense, solid bodies. Imagine making a snowball. You start with loose flakes, but the more you compact them, the more solid and uniform the sphere becomes. Natural gravitational formation does not produce hollow structures. It results in bodies with a fairly consistent density throughout. If you were to slice a natural comet in half, you would find the same basic material from the core to the crust. Yet, 3I divided by Atlas seems to defy this basic law of cosmic formation. Harvard astrophysicist Avi Loeb has closely examined the object's rotational dynamics, how it tumbles on its axis as it journeys through space. For a solid object of its apparent size, the observed rate of spin is far too slow. Yet, for an object with its measured mass, the spin is too stable. The only way to make the conflicting observations work together, to reconcile the math, is to remove a vast amount of mass from its interior, creating an internal cavity, a hollow structure, but that is only the start of the impossibilities. The second anomaly points to something even more disturbing. 3I divided by Atlas is slowing down. Allow me to explain precisely why this is a direct violation of fundamental physics. As a natural comet nears the Sun, its behavior is predictable. The Sun's radiation heats its surface, causing frozen gases and ice to sublimate directly into space. This outgassing creates jets that function like small rocket thrusters, invariably pushing the comet away from the Sun and causing it to accelerate along its path. This is basic Newtonian physics, observed in countless comets over centuries. Oumuamua, to be sure, behaved strangely. It accelerated away from the Sun without any visible outgassing to explain the push. That phenomenon was a deep mystery that triggered years of intense debate. But the key point is, it accelerated outward, moving in the direction one would expect from solar radiation pressure. 3I divided by Atlas is doing the exact opposite. Between September 23rd and September 26, 2024, velocity data from the James Webb Space Telescope, along with readings from ground-based radar and Doppler shift analysis from Martian orbiters, all converged on the same impossible conclusion. The object's velocity relative to the Sun decreased from 68.2 kilometers per second to 67.9. Now, a change of 0.3 kilometers per second may not sound like much, but in celestial mechanics, it is a colossal anomaly. Natural variations in velocity measurements from instrumental error would be random. What we are seeing is a clear, directional, and sustained deceleration confirmed across multiple independent observation platforms. There is simply no known natural mechanism that can apply a braking force to an object moving at this speed through the vacuum of interplanetary space. Solar radiation pushes things away from the Sun. It doesn't slow them down. Outgassing jets accelerate comets. They never act as brakes. And the Sun's gravity only pulls objects inward, making them speed up, not slow down. So, what could possibly be causing this? Let's consider the possibilities, each one more profound than the last. The first hypothesis involves a solar sail, but one operating in a reverse thrust mode. Instead of using the pressure from solar photons to push away from the Sun, picture a vast, highly reflective surface angled perfectly to create drag against the stream of light, like a cosmic parachute. This would demand an incredible degree of specific, stable orientation, holding a precise angle against the incoming sunlight. And here is a captivating detail. Spectroscopic readings have confirmed that 3I divided by Atlas has an exceptionally reflective surface, far more like a mirror than the dark, dusty nucleus of a typical comet. The problem with this theory: natural objects are not stable. They tumble end over end. This chaotic rotation would make it impossible to maintain the sustained orientation needed for such a maneuver. Yet, 3I divided by Atlas rotates with what observers have called clockwork precision, maintaining a stability that should not be possible for a natural body billions of years old. The second theory points to some form of active propulsion that we are unable to see. This could be an electromagnetic drive system that generates thrust without a visible exhaust, or perhaps an ion propulsion technology so advanced that its emissions are below the detection threshold of our instruments. The strange green aura that has been documented around the nucleus by several observers could even be a clue, perhaps a byproduct of ionized plasma manipulation, part of a propulsion system we do not yet comprehend. But this explanation faces an insurmountable obstacle. Any propulsion system powerful enough to alter the velocity of such a large object would require a colossal energy source, one capable of functioning for millennia in the frozen emptiness of interstellar space. What natural power source could possibly achieve such a feat? The third possibility suggests something even more extraordinary. What if 3I divided by Atlas is intentionally using gravitational encounters as a tool to modify its own trajectory? Its flyby of Mars on October 3rd resulted in a measurable change in its velocity. Looking ahead, its path is charted to pass remarkably close to several other major bodies in our system. Venus in early 2025, followed by a close encounter with Jupiter in March 2026. A statistical analysis of these alignments reveals that the timing is almost impossibly precise. The probability of this sequence of flybys occurring by sheer random chance is calculated to be less than 1 in 50,000. It's analogous to flipping a coin and getting heads 15 consecutive times. While mathematically possible, it is so staggeringly improbable that you would have to suspect the game is rigged. All three of these theoretical paths lead to the same deeply unsettling destination. This is not some random piece of cosmic rock drifting aimlessly through our solar system. If 3I divided by Atlas is actively braking, it is performing a controlled, deliberate maneuver. It is not behaving like a tourist passing through for a brief visit. It is methodically reducing its speed, as if it intends to stay, extending its time inside our system for purposes we can only begin to speculate on. And this brings us to what may be the most alarming piece of this entire puzzle: the wall of institutional silence. Following the object's closest approach to Mars on October 3rd, 2024, the expected comprehensive data releases from the missions that observed it never came. NASA cited a government shutdown that conveniently began just 2 days before the flyby, a bureaucratic maneuver that effectively silenced public communication at the precise moment this historic event was unfolding. The European Space Agency claims its data is still being processed, and China's Space Agency, an organization that usually releases imagery within days, has made no official comment whatsoever on the observations from its Tianwen-1 probe. This pattern is not new. When Oumuamua passed through in 2017, certain key radar measurements and spectroscopic analyses were not made public for months. When Borisov followed in 2019, we saw similar delays. Now, with 3I divided by Atlas, history seems to be repeating itself with an unnerving consistency. In our era of instantaneous global information, silence itself is a form of communication. It is a message delivered through its own conspicuous absence. But here is a thought that truly haunts my nights. On October 29th, 2024, 3I, divided by Atlas, reached perihelion, its closest point to the Sun, at a distance of about 1.36 astronomical units. This put it just inside the orbit of Mars, where it was subjected to the most intense solar heating and radiation of its entire journey. Crucially, this event took place while the object was on the far side of the Sun from our vantage point on Earth. We were blind. Our most powerful telescopes were rendered useless, aimed directly into the Sun's overwhelming glare. This created an observational blackout that lasted for weeks. And it was during this period of blindness that something may have happened, shielded entirely from our view. A natural comet typically does one of two things at perihelion. It either shatters catastrophically as the thermal stress creates deep fractures, or it develops a magnificent, enormous tail as its volatile materials are violently boiled off into space. But when 3I, divided by Atlas, re-emerged from behind the Sun in late November 2024, it was completely unchanged. It was perfectly intact. There was no evidence of fragmentation or structural failure. For an object supposedly made of loosely packed ice and dust, this level of durability is extraordinary. Comets are fragile. They are cosmic snowballs that are easily broken apart by thermal stress. A hollow comet moving at over 200,000 kilometers per hour should have been torn to pieces by structural instability alone, especially when exposed to the intense solar furnace at perihelion. And yet, it survived. Harvard's Avi Loeb has offered an even more provocative idea. In a recent paper, he theorized that 3I divided by Atlas might be a transport vessel carrying smaller objects shielded within its hollow interior. He likened it to a dandelion spreading its seeds on the wind, suggesting it could be a parent ship designed to deploy probes at the most opportune moments during its transit of our solar system. And perihelion, the very moment it was hidden from our view, would have been the perfect window to release them. Consider the implications. If smaller, secondary objects were released during that observational gap, they could now be moving silently throughout our solar system on trajectories we cannot predict, with intentions we cannot possibly know. The Galileo project, which Professor Loeb directs, is now specifically scanning the skies for any new anomalous phenomena. If unknown objects suddenly begin to appear, or if our sensor networks start detecting events that defy conventional explanation, the timing correlated with the perihelion passage of 3I divided by Atlas would be impossible to ignore. So, where are we now? We are faced with an object from outside our solar system that is actively defying the laws of physics. It appears to be hollow when it should be solid. It is slowing down when it should be speeding up. Its trajectory appears to be intelligently guided when it should be random. Its resilience suggests robust engineering when it should be fragile. And the very institutions charged with watching our skies have become strangely and inexplicably silent at the exact moments when we need transparency the most. As a physicist, I do not view this situation as a crisis that demands fear or denial. I see it as an invitation to fundamentally rewrite our understanding of the universe. Every anomaly is a message, a lesson hidden within its strangeness. Every deviation from the expected is a question we have not yet learned how to ask. 3I divided by Atlas will continue its journey through our solar system through 2025 and beyond. It passed within 167 million miles of Earth on December 19th, 2024, and in March of 2026, it will have its close encounter with Jupiter. This will be another chance for a gravitational interaction, another opportunity for a potential course correction. The European Space Agency's JUICE mission will be there to witness it. We are on the cusp of a real-time confirmation or refutation of something truly extraordinary. Unlike Oumuamua, which was gone before we could properly study it, 3I divided by Atlas is giving us months, possibly years, to collect data and to truly comprehend what it is we are seeing. Whether this visitor is ultimately proven to be a natural phenomenon or something far more significant, it has already achieved something remarkable. It has forced the collective human mind to grapple with possibilities we have always relegated to the realm of fiction. The universe has absolutely no requirement to meet our expectations or to fit into the neat boxes of our current understanding. Once in a great while, it sends a mysterious messenger streaking through our cosmic backyard to remind us that the greatest discoveries do not come with easy answers. They come bearing better, deeper questions, questions that propel human consciousness forward into territories we never dreamed we would explore. And perhaps that is the true identity of 3I divided by Atlas. Not an end, but a beginning. The opening chapter in a dialogue far grander than we ever conceived, a story written not with human words, but in the silent, elegant dance of celestial objects across the infinite stage of space and time.